Look at the window next to you, or the glass in your hand, or the screen you're reading this on right now. You touch this material every single day. You don't think about it once, but the real answer behind where it came from is far stranger than you'd expect. Glass shouldn't exist, not the way it does. Sand doesn't melt at cooking temperatures. It doesn't melt in a bonfire. It doesn't even melt in most ancient furnaces. To turn ordinary sand into glass, you need heat above 1700 degrees Celsius. That's hotter than lava. That's hotter than almost anything a human could produce on purpose for most of history. So here's the question. If nobody could reach that temperature, how did glass get invented at all? The answer starts with an accident, or maybe several accidents in several places, thousands of years apart. Archaeologists have found glass beads in Egypt and Mesopotamia dating back to around 3500 BCE. But these weren't crafted on purpose, not at first. They were byproducts, leftovers, the unintended result of something else entirely.
Picture a Bronze Age metal worker. He's smelting copper or firing pottery. The kiln is packed with sand, ash, and natron, a natural mineral salt used for drying and preserving. The fire burns hot. Hotter than usual maybe because of a particular mix of fuel or wind or luck. And in that heat, something happens that nobody intended. The sand doesn't just sit there. It reacts. The ash lowers the melting point. The natron lowers it further. What should have needed 1700 degrees now only needs around 1000. Still blistering, still dangerous, but suddenly achievable. And when that molten mixture cools, it doesn't turn back into sand. It hardens into something new, something smooth, something that catches light in a way nothing else in the natural world does. Nobody planned this. Nobody woke up one morning and decided to invent glass. It was found, not designed. And that changes everything about how you should think about invention itself. You tend to imagine discovery as a straight line. A genius has an idea. The genius builds the idea. The idea becomes real. But glass wasn't born from a plan. It was born from proximity, from humans standing next to fire long enough, often enough, that eventually the fire showed them something they weren't looking for. The historian Robert Friedel, who spent decades studying the history of materials and technology, has argued that most transformative human materials emerged this way, not through deliberate invention, but through what he calls contingent discovery. Copper smelting, bronze, even the earliest ceramics, all stumbled into, not strategized. Think about what that means. The most important materials in human history didn't come from someone trying to invent them. They came from someone paying close enough attention to notice when the world did something unexpected. By around 1500 BCE, something shifts. Glassmaking stops being an accident and starts being a craft. In Mesopotamia and Egypt, artisans begin deliberately combining sand, natron, and lime in controlled ratios. They build kilns specifically designed to trap and hold heat. They discover that adding certain metal oxides changes the color. Cobalt turns glass a deep blue. Copper turns it green or red, depending on the oxygen in the furnace. Manganese can make it nearly clear. This is no longer luck. This is chemistry, practiced by people who had no word for chemistry, who had never heard of atoms or oxidation states, but who understood, through pure repetition and observation, that certain ingredients behaved in certain ways every single time. For centuries, glass stays rare. It stays expensive. Small beads, small vessels, often reserved for the wealthy, sometimes valued as highly as gemstones. Producing it required fuel, skill, and time that most people simply didn't have access to. Then, around the 1st century BCE, something happens on the Syro-Palestinian coast that changes the trajectory of glass forever. Someone invents glassblowing. A glassmaker discovers that if you gather molten glass on the end of a hollow tube and blow air into it, the glass expands, it stretches. It becomes a bubble that can be shaped, widened, pulled into a vessel in a fraction of the time it used to take to carve or mold one.
This single technique turns glass from a luxury item into something almost anyone could eventually own. Production speeds up dramatically. Costs drop. Within a few generations, glass vessels start appearing not just in palaces, but in ordinary Roman households. The classicist and archaeologist Marianne Stern, who has extensively studied Roman glass production, has noted that glassblowing represents one of the fastest technological shifts in ancient material culture, transforming an elite craft into something approaching mass production almost overnight by ancient standards. You should sit with that for a second. A material that once required volcanic-level heat, that was once so rare it was traded like jewelry, became something a regular Roman family might use to store olive oil, all because someone figured out how to breathe into it. Roman engineers took it even further. They began experimenting with pouring molten glass into flat molds, producing the first crude windowpanes. These early panes were thick, greenish, and full of tiny bubbles, nothing like the flawless glass you'd expect today. But for the first time in human history, light could enter a building while weather stayed outside. Before this, a window meant a hole in a wall. Now it could mean something else entirely, a barrier that let in brightness without letting in cold, rain, or wind. Archaeological excavations at sites like Pompeii have uncovered window glass fragments still fitted into bronze frames, evidence that even mid-tier Roman homes were beginning to adopt this once unthinkable luxury. But here's where the story gets stranger, because glass wasn't just changing what people owned, it was changing what people could see, and not just outward, but inward. Centuries later, in the medieval period, glassmakers in Italy discover something new. If you grind glass into a specific curved shape, it bends light in a predictable, useful way. It magnifies. The earliest eyeglasses appear in northern Italy around the late 1200s, and for the first time in human history, people whose vision failed with age don't simply lose the ability to read. They get more time, more years of clear sight, of literacy, of work.
Then glass bends light in the other direction too. Lenses ground for magnification eventually lead to the first microscopes and telescopes. Suddenly, humans can see bacteria. They can see the moons of Jupiter. A material that started as an accidental byproduct in a Bronze Age kiln ends up expanding the boundaries of human knowledge in both directions at once, inward toward the invisibly small and outward toward the impossibly distant. The science historian Vincent Ilardi, who studied the origins of eyeglasses extensively, described the invention of corrective lenses as one of the most quietly transformative technologies in human history, one that receives far less attention than it deserves given how directly it reshaped who could participate in reading, scholarship, and skilled work. Glass didn't stop reshaping the world after the telescope and the microscope. It kept going. It kept finding new jobs to do. By the 1600s, Venetian glassmakers on the island of Murano had turned glassmaking into something closer to an art form and the state secret at the same time. The Venetian government valued the craft so highly that glassmakers were forbidden from leaving the city under threat of severe punishment. Their techniques for producing exceptionally clear, colorless glass, known as cristallo, were treated the way a modern nation might treat classified military technology. A material born from an accidental Bronze Age kiln had become powerful enough to warrant government secrecy. Mirrors tell a similar story. Before glass, humans checked their reflection in polished metal, or still water, or highly bussed stone. All of these were dim, distorted, unreliable. Venetian craftsmen eventually developed a technique of backing glass with a thin layer of tin and mercury, creating the first truly clear mirrors in history. For the first time, people could see themselves the way others saw them: sharp, detailed, undistorted. Historians studying the psychology of the period have noted that this shift coincided with major changes in European portraiture, fashion, and even early ideas about individual identity. A person's sense of self quite literally sharpened alongside the glass.
Now, fast forward again, past the Industrial Revolution, past the invention of tempered glass, past the float glass process developed in the 20th century that allowed for the mass production of the flawless, uniform window panes now found in nearly every building on Earth. Which brings you to fiber optics. In the 1960s, researchers including Charles Cow discovered that if you purify glass enough, removing nearly every impurity, you can send pulses of light through a thin strand of it across enormous distances with almost no signal loss. Cow's work, which later earned him a share of the Nobel Prize in Physics, laid the foundation for the fiber optic cables that now carry the internet itself. Every video call, every message, every search request likely travels at some point through a strand of glass thinner than a human hair. Sit with that for a moment. The same basic material, the same chemistry discovered by accident in a Bronze Age furnace now forms the physical backbone of global communication. Sand melted by mistake 3,500 years ago somehow leads directly to the fiber optic line beneath the ocean carrying this very sentence toward you. Think about that chain for a moment. Sand, ash, accidental heat, a Bronze Age craftsman who had no idea what he was creating, and from that single unplanned moment, a path that eventually leads to eyeglasses, telescopes, microscopes, windows, mirrors, fiber optic cables, and the very screen in front of you right now. None of it was inevitable. At almost every point along the way, it could have stopped. The heat could have been slightly lower. The natron could have been swapped for something else. The glassblower on that coastline could have kept the technique secret instead of letting it spread. But it didn't stop, because once humans notice something useful, they tend not to let it go. There's something worth remembering in all of this. You live in a world built on materials that weren't supposed to exist. Bronze wasn't supposed to exist. Steel wasn't supposed to exist. Glass especially wasn't supposed to exist. Every one of them came from someone standing close enough to a fire, paying attention long enough to notice the moment the ordinary turned into something else. So the next time you look through a window, or set down a glass, or glance at the screen in your hand, remember what it actually is. Not a manufactured object, not a designed material, but the descendant of an accident. A byproduct that outlived the fire that made it and ended up shaping how far humans could see, in every sense of the word. You've been looking through the answer this whole time.